This video goes with lesson 9.2, inference about the difference between two proportions. This one will cover the confidence intervals only. Example 3, a class of 30 computer science students were taught introductory computer programming with an innovative teaching method that used a graphical interface and drag and drop methods of creating computer programs. At the end of the class, 23 of these students said that they felt confident in their ability to write computer programs. Another class of 40 students were taught the same material using a standard method. At the end of the class, 25 of these students said that they felt confident. Assume that each class contained a simple random sample of students. Construct a 95% confidence interval for the difference between the proportions of students who felt confident. Okay, first thing we ought to do is write down the stuff that we know. Okay, things we know. We know we have two samples. In the first sample, we know that there are 30 students. It told me so right here. Okay, and let's see, at the end of the class, we've got 23 of them who are feeling pretty confident about their abilities. And then we've got another sample of 40 students. And at the end of their class, 25 of them felt pretty confident. And let's see, we're supposed to do a confidence interval for 95%. So our confidence level here is going to be 95%. Okay. Now, in order to find a confidence interval for the proportion, let's go back and look at the directions here. We are going to have to figure out the value of the point estimate, which is P1 hat minus P2 hat. Now, that's just the proportion from the first sample minus the proportion from the second sample. Okay, so in our case, we're going to be looking at 23 divided by 30 for our P1, and then 25 divided by 40 for our P2. All right, so P1 with the hat is going to be 23 divided by 30. And if we put that into our handy dandy calculator, it's going to give us 0.7667 once it's been rounded off. And when we look at the P2 hat, this was going to be 25 divided by 40. And in the calculator, this is going to give me 0.625, and this one I did not have to round because that decimal did actually terminate there. Okay. All right, so P1 with the hat minus P2 with the hat, this is going to be 0.7667 minus 0.625. And in the calculator, this is going to give me 0.1417. And this is our point estimate. Okay, let's go back and see what we need to do next. So we've done this. Now we have to find our critical value corresponding to the desired level from the last line of table A3 or from table A2, or you can do this with technology, and the ALEKS calculator is a really big help here as well. I'm going to use table A3, and what we're going to need to do is we're going to go to table A3, and we are going to go to the Z line. This is the very last line on table A3, and it has a Z out there to the left. And we're going to be reading across to 95% because that is my confidence level. All right, so here's table A3. And remember I said I'm going to go all the way to the bottom. And down here, you can see that letter Z there. This is the one I call the Z line. Remember, we're going to be 95% confidence, so I'm looking at the percentages down here across the bottom. There's 95%. The critical value that goes with it is right above it on the Z line, 1.960. And that is what we're going to use for our Z alpha over 2 number, 1.960. All right, the critical value. Z with the subscript alpha over 2 is going to be 1.960. Okay, all right, now what do we want to do next? We found our critical value. Now we want to compute the standard error. Now we've got this crazy looking square root thing that we're going to put it in there, but remember we've already figured out what P1 hat is, so we know what that and that are. We know N1, remember that's the sample size for our first sample. We already computed this one, and we've got that as well. So we have everything that we need. We just need to put it in the calculator correctly. All right, so let's take a look at what this is going to be. The standard error is going to be it's not 1, it's P1, sorry. So it's 0.7667 times 1 minus 0.7667. This is going to be divided by our N1, which we said was 30, plus, now we're going to do P hat 2, so this is 0.625 times 1 minus 0.625, and we're going to divide that by 40, and then remember we're supposed to square root all of this. Now if you're using the calculator that is recommended for the class, you can actually put all this in at one time in the calculator. If you're not comfortable with that, you can put it in bits and pieces at a time and round your answer. Just know that your final answer is going to be slightly off from mine, and that's okay, because as long as you've done the process correctly, the rounding I'm not going to be very picky about. Okay, so I think I did take this and put it in the calculator at one time, and I got 0.1087 for my standard error. All right, let's go back and check out our directions. We've got our standard error done. Next thing we want to do, we've got to figure out the margin of error. Now the margin of error is just going to be the critical value times the standard error there. So our margin of error is going to be our critical value, 1.960 times 0.1087. And in the calculator, this is going to give me 0.2131. And now that I have my margin of error, now I'm going to take my point estimate, and I'm going to take my margin of error, and I am going to create my confidence interval by adding them and subtracting them together. So our confidence interval will be 0.1417 minus 0.2131 and 0.1417 plus 0.2131. And when I calculate those in my calculator, this is going to give me negative 0.071. That's from these two, comma, instead of the and sign here. And I'm going to add those together, and that's going to give me 0.355. So it looks like my 95% confidence interval is right here. negative 0.071, and 0.355. So we are 95% confident that the difference between those proportions falls in between negative 0.071 and positive 0.355. Example 4. In a test of the effect of dampness on electrical connections, 80 electrical connections were tested under damp conditions, and 130 were tested under dry conditions. 20 of the damp connections failed, and only 8 of the dry ones failed. If possible, construct a 90% confidence interval for the difference between the proportions of connections that fail when damp as opposed to dry. If it's not possible, explain why. Okay, this one actually ends up being not possible. And it all stems from the fact that we have to have at least 10 items in each of our categories here. Okay, now what that means is that the number of failures we have right here is 8, and we don't have 10, so we can't even bother to try and do a confidence interval on this because that number is not 10 or more. So we would say that the number of failures for dry connections is less than 10. In other words, 8, which is our number of failures, is less than 10. And remember, we have to have at least 10 in order to be able to do this.